Welcome back to lesson 23, to the lesson activities that I didn't get a chance to finish up in the previous video. So we're going to continue right now with problem number 6. We're going to finish today 6B and 6C. So let's just review what the directions were for activity number 6. Answer each of the following questions and write each of the polynomial functions in completely factored form. That should say completely right there. Completely factored form. Each comes with some suggestions on how to proceed. So let's just take a look at this polynomial right here, this function. So right now, g of x is actually a subtraction problem. It's 6x cubed, take away 9x times x plus 1 times x minus 1. So as it's written, this is a subtraction problem. And our job to get this, first we need to get this in polynomial form and simplify each one of these boxes. Well, the first one's already done for us. It's 6x cubed. So now we need to multiply out these factors here. Now, this is an area of math that sometimes students get very confused with. So I just want to review for you really quickly the associative property. The associative property of mathematics says that if you multiply more than two factors, for example, a times b times c, then what you can do is you have the right to multiply the first two factors, a, b, get your product, and then multiply that by c. Or you can multiply b times c, get the product, and then multiply it by a. You can also rearrange through commutativity the b and c term and multiply a times c first if you'd like, and then multiply by b. So sometimes students confuse this with the distributive property. So you have 9x here, you have the factor x plus 1, and you have the factor x minus 1. So if I were doing this, I would use the associative property to multiply these two factors first, because I know from experience, and I hope by now you do too, that when you see two factors like this, we call these conjugates because they look the same except for their operations are inverse. You have an addition and subtraction. When we multiply that, we will get x squared minus 1 as a result. So I still haven't completely simplified my second box, or what we call our second term here. So let's see if we can do that. So we've got 6x cubed minus, now we're going to take 9x and multiply it times x squared. So you see we are going to use our distributive property now, 9x cubed. And now we're going to take our 9x and multiply it by -1. But remember that this subtraction sign goes along with the 9x. So we've got -9x cubed, and then we have plus 9. So that's one area you have to be a little bit careful of, is that plus 9. Okay, 9x, excuse me, 9x. All right, so let's take a look at this now. We've got 6x cubed minus 9x cubed plus 9x. So that's going to give us 6x cubed minus 9x cubed gives us -3x cubed plus 9x. So the polynomial function is simplified to be a -3x cubed plus 9x. Okay. Now that's going to be a lot easier to factor now that I've simplified it. So before I do that, let's see if we can answer some, since this is in polynomial form. And it's often easier to answer some of the questions that we're going to ask below when it's in polynomial form. So let's take a look at this. The leading coefficient, -3. The degree of the polynomial, 3. The number of x-intercepts will also be the same as the number, the degree, which is 3. The zeros, we're about to find those. And then once we find the zeros, then we can write the factors that correspond to those zeros and completely factor this. Okay, so remember, it's really critical that whatever your leading coefficient is in the polynomial form, which is here, the -3, will also be the leading coefficient down here. So you can already write the polynomial in completely factored form by writing in a sub 3, which is your leading coefficient here. So we know we're going to have 3 factors because we have the same number of factors and intercepts as the degree. Okay. Now let's take a look at factoring this. G of x equals, well, my greatest common friend, GCF here, is -3x. I always will pull out a -3x when my first term here, my leading term, has a negative leading coefficient. That leaves me with x squared take away 3. Now you might say, I can't factor that. But yes, you can, because this is the difference between squares. It doesn't have to be a perfect square here. I mean, if this was x squared minus 9, you'd write x plus 3, x minus 3, because 3 would be the square root of 9. But it doesn't matter. You can write the 2 conjugates, and the number that goes in each of these spots is the square root of 3. So now I've completely factored g of x. I'm going to set it equal to 0 to find my zeros. And I can see that my first 0 is when x equals 0. My second 0 is when x equals negative square root of 3. And my third 0 is when x equals positive square root of 3. So my 3 zeros are 0 plus and minus the square root of 3. Again, 3x intercepts, degree is 3. Now I can take each of these and put it into my factored form. So when one of my zeros is 0, I could write x take away 0 here, but it's a lot easier just to write x. So I'm going to take this and bring it right down and call it x. Now my next factor is going to be x. Remember, your factors are always in x take away whatever your 0 is. In this case, we have 3 zeros, and we use C to denote our zeros. So we have C1 is 0, so x take away 0 gives me this one right here, x. My next one is x take away a negative square root of 3, and then x take away a positive square root of 3. So when I simplify this, x take away a negative square root of 3 is x plus square root of 3 and x minus square root of 3, just like we had up there. We had already completely factored this anyway. So how many linear factors? We have 3 linear factors. 1 degree, 1 degree, 1 degree, 1. Check out each 0 of the polynomial. So let's do that. We'll check out each 0 of the polynomial. I'll probably do 2 for you and leave you 1 to do on your own. So let's put in 0. Let's check out 0. We have to go back to our original polynomial in case we made a mistake somewhere along the line. We would never find it if we put our zeros in anywhere along here. So let's put a 0 in. We get 6 times 0 cubed minus 9 times 0 times 0 plus 1 times 0 minus 1. We get 0 minus 0 equals 0. You're a happy camper. So that checks. Okay, let's do a square root of 3. So we've got, let's take the positive square root of 3. So I'm going to change my color now. 6, whoops. I'm going to do 6 times the square root of 3 cubed minus 9 times the square root of 3 times the square root of 3 plus 1 times the square root of 3 minus 1. There we go. So let's take a look at this and simplifying this. Well, the square root of 3 cubed, you could write like this if you needed to. And the square root of 3 times the square root of 3 is 3. So this is 6 times 3 square roots of 3, which is 18 square roots of 3. So that's going to be the first term. That's just 6x cubed. That's all done now. It's going to be 18 square roots of 3. Now, one of the reasons we showed you the associative property earlier was so that you could use that idea right here. When you multiply conjugates, you square each term. So the square root of 3 squared is 3. There's always a subtraction because these signs are inverses of each other. And then 1 squared. So we got the 1 there. And now what do we have out front? We have 9 square roots of 3. So we now have, I was giving you a little time to catch up. We now have a multiplication problem, but I'm going to simplify 3 take away 1 to be a 2. So that gives me 9 times square root of 3 times 2, which is 9 times 2 times the square root of 3, because the order doesn't matter when I multiply. And now we get 18 square roots of 3, take away 18 square roots of 3, which is 0. Happy camper. So you do this now for f of negative square root of 3. You should also come out with a 0. All right, let's take a look at our final problem here. C. So we want to completely factor this. And there's no common factor all the way across. I can't use any of my typical factoring techniques. So when I have a problem like this, I hope that I have a graph to help me out so that I can find one integer valued 0, a nice friendly 0. And you can see here that I do have some help that negative 2 is a 0. Then I can use the fact that x equals negative 2 is a 0. I can use my factor theorem to now say that that becomes x plus 2 as a factor. Because you can see if you plug that negative 2 right in there, you'd get negative 2 plus 2 is 0. So now you have a factor. So to find your remaining factor for this cubic, you just do long division. X plus 2 divides into x cubed minus x squared minus 5x plus 2. So x goes into x cubed, x squared times, and x squared multiplies each one of these. So I get x cubed plus 2x squared. Remembering you have to subtract both of these, so both signs change. That goes to 0. You got negative 1x squared, take away 2x squared is negative 3x squared, and you bring down your next term, which is negative 5x. X goes into negative 3x squared, negative 3x times, and now you start this process all over again. You get negative 3x squared minus 6x. You have to change the signs of both of these when you subtract. That goes to 0. You get x plus 2. Yippee. X plus 2 goes into x plus 2 one time. You change the sign of both terms, and you get a nice 0. So now you have factored the function h into the following two factors. X plus 2, and remember we got that right from the graph to help us. And then we use long division to get this second factor, x squared minus 3x plus 1. So we haven't completely factored this because we still have to factor this quadratic trinomial. And there's no factors of 1 that add up to negative 3. So the only way we can factor this, because to find our zeros, we have to set each one of these equal to 0. And when you set this x squared minus 3x plus 1 equal to 0, you're solving a quadratic equation. So let's bring that down here. Put a line here. X squared minus 3x plus 1 is 0. So the only way we can solve this is with the quadratic formula. So let's see. A is 1, B equals negative 3, and C is 1. So to solve for x, we start off with x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So this equals 3 plus or minus the square root of 9 take away 4 all over 2. So one of our zeros is 3 plus the square root of 5 over 2. So that looks like this. X take away 3 plus the square root of 5 over 2. And the other zero is 3 take away the square root of 5 over 2. So x take away 3 minus the square root of 5 over 2. So that's the polynomial that we started out with in completely factored form. The leading coefficient is a 1 here because it was a 1 up here. Remember that leading coefficient never changes. So the leading coefficient is 1. We have 3 linear factors. 1 plus 1 plus 1 is 3 for our degree. If we go back to the polynomial form, we see 3 is the highest power in the polynomial. The number of x-intercepts is 3. The zeros of the polynomial are 0, 3 plus the square root of 5 over 2, and 3 minus the square root of 5 over 2. Write this in completely factored form. I did. And you can say that. Here it is. You can just take that and put it right down here. I think this was called h of x, if I recall correctly. That should be h of x, not f of x. And then how many linear factors? Well, we have a degree of 3. We have 3 linear factors. Check each zero of the polynomial. I would consider checking these 2 zeros when you have a cubic polynomial to be an optional challenge. I would put that as optional and as a challenge. So for those of you who like challenges, give it a shot. We can throw the 0 in pretty quickly, right? We have 0's a nice easy one to check. 0 cubed minus 0 squared minus 5 times 0 plus 2. That's our original. Oh, I made a mistake here. It's not 0. It's negative 2. Right there. Look, I'm trying to go too fast to finish up this video for you. The 0 here is negative 2. So let's erase that. Well, it's nice to see when you make a mistake, this does not equal 0. So that's the beauty of finding zeros, is that if you put it the wrong one in, like I just did, then it doesn't give you a 0. Cool. All right, so let's try this again. If I plug in, and this should all say h of the 0. So let's see, we get negative 2 cubed minus negative 2 squared. Notice how I have to put parentheses anytime I have an even exponent and my base is negative. It must be in parentheses. Minus 5 times negative 2 plus 2. So this equals negative 8 minus 4 plus 10 plus 2. Negative 12 plus 12 is 0. Okay. So that's it for lesson 23. Lots of activities in lesson 23. If you have any questions, you can always email me at any point, and I'll be glad to help you out.